Right now, an object we call 3IATLAS is speeding through the most intense part of our solar system. The 3I in its name tells us it's only the third confirmed visitor from interstellar space ever recorded. Think about that. A traveler from another star system, right in our cosmic backyard. Its path is what astronomers call hyperbolic. That's a fancy way of saying it's on a one-way trip. It came from the vast emptiness between stars. It's making a sharp turn around our sun, and then it's heading right back out into the void, never to return. For months, we've been tracking its every move with a global network of telescopes. Each observation helps us pinpoint its journey. On October 29th, it reached its closest point to the sun, an event called Perihelion. It plunged into a gravitational furnace where sunlight is 30 times stronger than what we feel here on Earth. At that moment, 3IATLAS was screaming through space at 92 kilometers per second. That's nearly twice as fast as Earth's own journey around the sun. To put that into perspective, none of our most powerful rockets could ever hope to reach that kind of speed. This is pure celestial mechanics in action, the incredible acceleration you get when you slingshot around a star. For scientists, this perihelion pass is the main event. Before this, we could only catch glimpses of it in the twilight sky, but as it passed the sun, it entered the direct view of our solar observatories. Spacecraft like SOHO, Stereo, and the Parker Solar Probe. These are our eyes in the sky, watching as this interstellar object gets blasted by intense heat and radiation. Why is this so exciting? Because this extreme heat exposes the object's core. 3IATLAS is a comet, a giant ball of ice and dust. As it gets cooked by the sun, its ices turn directly into gas, shooting out into space in powerful jets. By studying these jets, we can learn what this comet is made of. Does it have the same chemical makeup as comets from our own solar system? Or does it carry the unique chemical fingerprints of a distant, alien stellar nursery? Scientists look for tiny, telltale wobbles in its path caused by these outgassing jets. These are known as non-gravitational accelerations, a slight push from the material escaping its surface. So far, the measurements show that 3IATLAS is behaving like a normal comet. There's no strange, unexpected propulsion, just the natural physics of ice turning to gas. Its path is stable, predictable down to a few dozen kilometers, even from hundreds of millions of kilometers away. But the sun isn't just a source of heat. It's also constantly blowing a stream of charged particles out into space, known as the solar wind. This isn't an empty highway, it's a turbulent river of plasma, tangled with the sun's magnetic field. When this solar wind slams into the gas cloud expanding from 3IATLAS, it creates a shockwave, almost like the bow wave of a boat. And things are about to get even more dramatic. Our sun is currently at solar maximum, a period of intense activity. It's been throwing out massive explosions called coronal mass ejections, or CMEs. These are giant clouds of magnetized plasma that travel through the solar system. By an amazing coincidence, several of these CMEs were predicted to hit 3IATLAS right as it was passing the sun. This gives us an extraordinary natural experiment. We get to see what happens when an interstellar object is pummeled by solar storms at the moment of its greatest stress. We might even see a disconnection event, where the comet S-ion tail is literally ripped away by the CME's magnetic field and swept into space. It sounds violent, but for scientists, it's an incredible opportunity. It's like having a free sensor in a part of space we can't easily reach. Watching how the comet reacts helps us understand the structure and speed of these powerful solar eruptions. So while some might be looking for instant, dramatic footage, the real work for scientists takes patience. The data from our solar observatories takes days to process. Every image has to be cleaned of cosmic rays, corrected for jitter, and calibrated before it can be interpreted. Scientific integrity depends on this careful work, and the observations don't stop there. Once 3IATLAS moves away from the sun's glare in late November, a global network of telescopes will lock onto it again. The goal is to see if its close solar pass has changed its trajectory in any measurable way. This isn't a crisis response, it's standard procedure for understanding how comets work. This is also our chance to do some deep chemical analysis. As light from the sun reflects off the comet's expanding gas cloud, we can split that light into a spectrum, like a rainbow. This spectrum reveals emission lines from different molecules, a chemical barcode. We'll be looking for things like exotic oxygen isotopes or different ratios of elements that could tell us, this didn't come from around here. These fingerprints are a portal into the chemistry of another star system, a clue to how planets and comets form elsewhere in the galaxy. World-class instruments like the James Webb Space Telescope are on standby. JWST can detect the infrared glow of carbon dioxide and carbon monoxide, which boil off at different temperatures than water ice. These observations could reveal even more about the comet's composition and its mysterious origins. After its fiery encounter, 3IATLAS will climb away from the Sun, crossing Mars' S orbit by mid-December and heading out toward Jupiter's S neighborhood by 2026. Because its path is hyperbolic, it won't be coming back. It will slowly fade into interstellar darkness, carrying a few atoms from our solar system with it. Even as it departs, we will continue to learn. Small asymmetries in its outgassing can change its spin, and watching that will teach us how comets evolve over time. This helps us understand not just interstellar objects, but the long-period comets from the edge of our own solar system, like the famous Hale-Bopp. This whole event is a beautiful convergence of different fields of science. We have orbital dynamics, thermophysics, plasma physics, and spectroscopy all coming together. We're piecing together a multi-dimensional portrait of a visitor from another star, tested by the full power of our own. 3IATLAS is now the third interstellar object we've studied, joining Oumuamua and Borisov. Oumuamua was strange. It showed no comet-like activity but was still accelerating. Borisov looked more like a conventional comet, but with a weird chemical mix. 3IATLAS provides another crucial data point. Is there a universal recipe for interstellar comets, or does every star system cook them up differently? We suspect it's the latter, that each one is a unique messenger from its home. Beneath all the technical data and complex models, there's a simple, profound human element. We are witnessing matter from another solar system being transformed by our own star. For all its cold equations, this is a story about curiosity, about how far the light of our understanding can reach before it, too, fades into the cosmic night. Thanks for joining us on this incredible journey. If you found this as fascinating as we do, don't forget to like this video and subscribe for more explorations into the wonders of our universe. See you next time.